Lesson 9, Chapter 16. Enable feedback so development and operations can safely deploy code by Group 4, Zach Allen, Sheldon Foster, and Ron Silva. So in this presentation, we'll cover using telemetry to make deployments safer, dev sharing pager rotation duties with ops, having developers follow work downstream, and having developers initially self-manage their production service, which will include defect counts and severity, type frequency of pager alerts, monitoring coverage, system architecture, deployment process, and production hygiene. So starting off, we need to understand that deploying code into production can be very stressful, but having better communication is always the best way to alleviate that stress. That is why having good telemetry is so important, because that's when you have good telemetry, you don't have to guess about the state of things. It's all right there in front of you. And it makes deployments less stressful for dev and ops, whoever is pushing the code to production. So using telemetry to make deployments safer, we need to actively monitor production telemetry, which lets us know immediately if there's an error in deployment. And if an error does happen, then we want to bring in whoever's needed to fix it as fast as possible and get that problem fixed. And if an error does make it all the way through into deployment, there's a few different things we can do to address that. We can toggle the feature off. We could use the fixed forwarding technique, or we can roll back to an older version.
Developers share page rotation duties with operation. Operation engineers downstream may have some problem when they making the application release. Many errors can appear during this process. Sometimes part of the team doesn't know about the failure that occur in the application, so the error can continue to appear in the operations. To make the work not so hard for the operations, the value stream can be part of the solution of the problem. All the people that have some participation in the development of the application can be part of the page rotation. So not only the operation can be part of the problem of the solution. Also, we can have any people from the value stream, like developers, development manager, and architects. Everyone in the value stream share the downstream responsibility of handling operation incidents. All the value stream can be benefits from receiving feedback from the customer and by having solution to the error that occur in the application. Have developer follow work downstream. Techniques in interaction and user experience design, or UX, we can call a contextual inquiry. One of the best way to learn from the user is by listening to them, making making a semi-structured interview. That way we learn how the user interact with the application, what kind of problem they may have, and how to find the best solution for them. Improve the user experience, help us to know how the application works. It's very helpful for the developer to know what happened to the user when they execute an application. When observing all the activities, faults, or improvement of the application, the developer will have a better feedback that will help him to make a better decision of his daily work. To observe the customer, we can see what are their expectation. We can see how the application works and what we can fix, what we can improve. Research methodology help us to understand how users are. what their expectations are when they are facing with the application.
As we've learned, it's important to develop and test work in production-like environments to ensure that it functions as expected. Unfortunately, production releases can still be disastrous because it's the first time this code is running in the actual production environment. This often happens because of operational issues that occur late in the software development process. If these issues aren't addressed, they can lead to software that is defective or difficult to operate. In many cases, these issues could have been avoided if there had been sufficient op resources to support the product teams and services that are already in production. Google's solution to this was to have developers self-manage their services in production for a period of time before handing them off to be managed by a centralized ops group. Having developers take on this responsibility initially helps to stabilize these services before ops engineers take over that responsibility. This makes the transition much smoother. Having ops engineers act as consultants throughout this process will help the product teams make their services production ready. For this solution to succeed, and also to reduce risk, organizations should establish launch requirements and guidelines that developers must meet before releasing code into production environments. These requirements should include the following questions. Does the application actually perform as designed? Is the application generating an unsupportable number of alerts in production? Is the coverage of monitoring sufficient to restore service when things go wrong? Is the service loosely coupled enough to support a high rate of changes and deployments into production? Is there a predictable, deterministic, and sufficiently automated process to deploy code into production? Is there evidence of enough good production habits that would allow production support to be managed by anyone else? And finally, is our service subject to regulatory compliance objectives, such as the Sarbanes-Oxley Act of 2002, PCI DSS, HIPAA, etc.? Does our service have high user traffic or high outage and impairment costs? Does our service store or transmit sensitive personal or financial data? Having developers initially self-manage production services while meeting these guidelines will help make the transition to having ops manage these services much smoother and more predictable. Then, as an additional step, we can create what is called a service handback mechanism. This occurs when a production service becomes fragile. We can return responsibility of managing that service by operations back over to development, where they have the expertise to address the issues that are causing it to be fragile. Ops engineers will then transition back into a consulting role. This can serve as an escape valve for operations, allowing them to continue to function in their operational duties and ultimately decreases the buildup of technical debt. In this presentation, we've learned that using telemetry to monitor our applications and environment will help make our deployments safer. We've learned about the importance of sharing pager rotation duties amongst development and operations so that the whole team takes ownership in making a quality product and solving any problems that occur. We've discussed the value of having developers follow their work downstream to see the impact that their decisions and efforts have on the customers who are using their services. Lastly, we've learned how the responsibility for managing these services can be shared by development and ops, initially by development and then, as requirements are met, transferred to operations, with the understanding that these responsibilities can be handed back to development if those services become fragile. If you have any questions, please let us know. Thank you for watching our presentation.